Your mouse sensor is probably more misunderstood than any other PC component. Let's fix that. Open your mouse right now. Go ahead, I'll wait. Pry off the bottom feet if you have to. What do you see? Probably a tiny black square about the size of a fingernail. That little chip is the reason your cursor moves, and it might be the most misunderstood component in your entire PC. Today, we're going to tear apart everything you think you know about mouse sensors. Today we're covering optical versus laser sensors, CPI, DPI, IPs, whatever those acronyms actually mean. Lift-off distance, motion processing. And most importantly, why your expensive gaming mouse might actually be holding you back compared to something half its price. This is Basic 101, and by the end of this video, you'll never look at your mouse the same way again. Before we get into optical versus laser, let's talk about what is actually happening when you move your mouse. Your desk isn't smooth. It is covered in microscopic hills and valleys, dust particles, scratches, everything. Your mouse sensor is essentially a tiny camera that takes thousands of pictures per second of your surface and calculates movement between them. No, really, your mouse has a tiny camera inside it. It takes high-speed photos of your desk, compares each photo to the previous one, and calculates how far you've moved based on how much the image shifted. That is the foundation of everything. The sensor has a light source, a lens, and an image sensor, similar to any other camera. The differences come from what kind of light source is used and how the sensor processes those images. Optical sensors use an LED, typically red, though some use infrared. This LED floods your surface with light, and the sensor picks up the reflections. The sensor then uses a technique called optical flow to track movement by comparing sequential images of the surface texture. The key thing about optical sensors is that they track actual physical textures. Every desk, every mousepad, even glossy surfaces have microscopic imperfections that the sensor can latch onto. The PMW 3360, the sensor everyone raves about, works this way. It captures genuine surface details and translates them into precise movement data. Optical sensors tend to be more consistent. They produce what is called one-to-one tracking, which means when you move your mouse 1 inch, your cursor moves exactly 1 inch on screen. No interpolation, no prediction, no artificial manipulation, pure, honest movement. The best optical sensors also have very low lift-off distance, meaning when you lift your mouse, the cursor stops moving almost immediately. We'll talk about why that matters later, but for now just know that optical sensors have a significant advantage here. Now let's flip to the other side, laser sensors. Laser sensors use a laser diode instead of an LED. Lasers are coherent light, they don't scatter like LED light does. This means the laser penetrates deeper into surfaces and can track on surfaces where optical sensors struggle, like glass or highly polished tables. Sounds better, right? Here is where it gets complicated. That deeper penetration is actually a problem for desktop gaming. Because the laser sees below the surface, it picks up information that doesn't correlate to physical mouse movement. It might track vibrations, microtextures at different depths, or surface inconsistencies that don't translate to actual movement. This can cause something called positive acceleration, where fast movements get tracked as even faster than they actually are. The Avago Adens 9800 is the infamous laser sensor that started showing up in gaming mice around 2012 to 2014. It was originally designed for notebooks, where you needed a sensor that could track on jeans, a couch cushion, or any random surface. Desktop gaming has completely different requirements. On a mousepad or desk, that laser sensor might actually be less accurate than an optical sensor. Yet many manufacturers stuck with it for years because it was cheap, already qualified for production, and frankly, most users wouldn't notice the difference. But competitive gamers, they noticed. This is a pattern we're going to see repeated, manufacturers prioritizing cost and convenience over actual performance. Let's move on to the spec everyone talks about, but almost nobody understands. Let's talk about DPI. You've seen this everywhere. Gaming mice advertising 25,000 DPI, 36,000 DPI, absurd numbers that sound impressive. Here is the problem. DPI is the wrong term. The correct industry term is CPI, counts per inch. But marketing loves DPI because it sounds familiar and bigger numbers sell products. Think of CPI like resolution. A camera that captures at 8K resolution sounds amazing until you realize it is capturing 8K of blurry, out-of-focus images. You can't fix blurry quality by increasing resolution. When you push a sensor way beyond its native resolution, you often get interpolation, which means the sensor is manufacturing intermediate values instead of actually tracking at that resolution. The PMW 3360, which many consider the best gaming sensor ever made, has a native maximum of around 12,000 CPI, but the sensor performs best at 400 to 3,200 CPI, far below its maximum capability. Gaming at 12,000 CPI on that sensor isn't better, it is actually worse. You are pushing it into interpolation territory, where it is generating fake data instead of reporting real movement. Real-world sweet spots: 400 CPI for precision work and competitive FPS aiming. 800 CPI is the most common competitive standard. 1,600 CPI is still very accurate, comfortable for most users. 3,200 CPI approaches diminishing returns. Anything above 6,400 CPI is marketing territory and often interpolated garbage. The vast majority of gamers, competitive or casual, will never benefit from anything above 3,200 CPI. Alright, time for another acronym: IPs, not in plane switching, that is monitors. In the mouse world, IPs means inches per second, and it refers to the maximum speed at which the sensor can track accurately. This spec is almost never marketed, which is wild because it is arguably more important than DPI. This is how fast you can move your mouse and still get accurate tracking. Imagine you are making a fast flick shot in an FPS game. If you move your mouse extremely quickly, say 60 inches per second, and your sensor can only track up to 50 IPs, your cursor will lag behind or worse, completely lose tracking. This is called sensor spinout. Your hand moved, but your cursor didn't. In a competitive game, that means a missed shot or a death. The PMW 3360 can track up to 400 IPs. That is fast enough that almost no human can outpace it. Budget sensors might only handle 150 IPs, still plenty for most users. But competitive gamers with fast reflexes might notice tracking issues during intense moments. Why don't manufacturers market IPs? Because it is expensive to test and certify high IPS ratings, and frankly, most consumers wouldn't understand it anyway. When you lift your mouse off the surface to reposition your grip, how far off the desk does the cursor keep moving before it stops? That distance is called lift-off distance, or LOD, and it matters more than you think. If your LOD is too high, say 3 millimeters or more, you might accidentally move your cursor while lifting or setting down the mouse. Lower LOD is generally better. Most high-quality optical sensors achieve LOD between 0.5 millimeters and 1.5 millimeters. Some gaming mice let you adjust LOD through software, which is a nice feature for customization. Laser sensors tend to have higher LOD because the laser tracks deeper and is more sensitive to the mouse being airborne. This is one of those cases where the technical advantage of laser deeper surface penetration actually becomes a disadvantage in real-world use. Here is where things get really interesting. The raw data from your sensor has to go somewhere, and that somewhere is your mouse's firmware, the tiny software program running inside your mouse that processes movement before sending it to your computer. This firmware can add all kinds of processing that sounds helpful but actually degrades performance. Most gamers never know it exists. Motion processing can include several techniques. First, prediction. The firmware tries to guess where you are going based on your movement pattern and sends that data ahead of actual tracking. This makes movement feel smoother but introduces input lag and inaccuracy. It is like the difference between driving with and without a GPS that anticipates turns for you. Sometimes it is right. Often it is wrong. Second, angle snapping, also called straight line correction. This is exactly what it sounds like. The firmware automatically straightens diagonal lines to make them look cleaner. Great for drawing, maybe terrible for gaming. Absolutely. You want your cursor to go exactly where you tell it, not where the firmware thinks you meant to tell it. This feature should be disabled for gaming, but often isn't. Third, acceleration compensation. This attempts to adjust for differences in how fast or slow you move. The problem is that everyone's movement patterns are different, and this compensation is rarely accurate. It often creates inconsistent feel where the same physical movement produces different cursor distances, depending on speed. Your muscle memory can't adapt because the output keeps changing. Fourth, smoothing. The firmware averages multiple readings to reduce jitter. This makes the cursor feel more stable, but adds latency because you are waiting for enough data points to average. High-quality gaming sensors like the PMW 3360 support raw input mode, which bypasses most of this firmware processing and sends sensor data directly to your computer with minimal manipulation. But this feature only works if the manufacturer implements it correctly, and not all of them do. Finally, let's address the elephant in the room. Why would a $120 gaming mouse have a worse sensor than a $30 option? Because sensors are just one component. A premium mouse might have better switches, superior build quality and materials, more ergonomic design, better scroll wheels, onboard memory, premium cables, software ecosystem integration, RGB lighting that is actually well designed, warranty, and support. All of those things cost money and contribute to the overall experience. But none of them make the sensor track better. Meanwhile, the $30 mouse with a PMW 3360 is benefiting from PixArt's years of refinement. The sensor was designed specifically for desktop gaming, has excellent IPS ratings, native one-to-one tracking, and low lift-off distance. It has been in continuous production for over 8 years, so manufacturing costs are optimized. Manufacturers can buy it cheap, implement it well, and deliver a great tracking experience at budget prices. So what should you actually look for? First, the sensor. Look for PMW 3360, PMW 3389, PMW 3370, or equivalent modern PixArt sensors. Avoid older Avago laser sensors unless you specifically want that behavior. If you see marketing copy that emphasizes DPI numbers above 10,000, without explaining native versus interpolated resolution, be suspicious. That usually means they're hiding the fact that their sensor is using interpolation to hit those numbers. Second, test the polling rate. Most mice run at 1000 Hz, which is fine. Some budget mice run at 500 Hz or even 125 Hz, which introduces input lag. Higher polling rates like 4000 Hz or 8000 Hz exist, but require stronger system performance and aren't necessary for most users. Third, consider your surface. If you are using a glass desk or very smooth surface, a laser sensor might actually be beneficial. For standard mouse pads and desks, optical is almost always better. Fourth, try before you buy if possible. Ergonomics are deeply personal, and no spec sheet tells you whether a mouse will feel comfortable during a 4-hour gaming session. And fifth, understand that software matters. The mouse's firmware, driver quality, and how it implements raw input mode all affect real-world performance. A great sensor with bad firmware implementation can perform worse than a good sensor with excellent firmware. Mouse sensors are one of those areas where marketing is almost completely disconnected from actual performance. Here is the bottom line. Mouse sensors are one of those areas where marketing is almost completely disconnected from actual performance. Big DPI numbers sell mice, low prices sell mice. Actual tracking quality, the thing that determines whether your cursor goes exactly where you want, is almost never discussed honestly. The PMW 3360 isn't impressive because it has the highest DPI. It is impressive because it tracks exactly what you tell it to track, at speeds no human can exceed, with minimal firmware manipulation. The next time you are shopping for a mouse, don't just look at the price tag or the DPI number. Ask what is actually inside. Your gaming performance might depend on it. If you found this helpful, smash that subscribe button and hit the bell. Drop a comment below. What mouse are you using and what is actually inside it? I'd love to know if you've ever checked. I'll see you in the next one.